All right, let's dive right into this explainer. Today, we're unpacking what is literally the most significant and, honestly, the most overhyped shift in AI since the Transformer itself. We're talking about the transition from AI that just talks to us to AI that actively works for us. But look, amidst all the noise, the endless buzzwords, and the wild marketing fiction out there, what's actually real? We're going to break down this massive evolution in how we interact with technology and explore the very real architectural challenges of making machines genuinely autonomous. So what's the actual difference? It all boils down to this. A chatbot answers questions, but an agent accomplishes tasks. Think back to late 2022 when ChatGPT first exploded onto the scene. It did something truly remarkable, right? It made AI feel entirely human. You typed a prompt, and it gave you this perfectly conversational, intelligent-sounding response. But here is the reality check we all need to internalize. A standard chatbot is essentially a dead end. It only answers. It can't check your calendar, it can't browse the live web independently to verify a claim, it can't execute a block of code, and it definitely can't modify a file on your desktop. At the end of the day, it doesn't actually do anything. Here's our roadmap for today. We'll be hitting 1. From oracles to actors, 2. The agent control loop, 3. Swarms and self-modification, 4. Why bounded autonomy matters, and 5. Hype versus reality. Let's jump in. Section 1. From oracles to actors. Let's see how this architectural shift fundamentally changes the game. Picture a traditional chatbot as an oracle. You ask it a question, it predicts the next best words based on a mountain of training data, it spits out a text response, and then it stops. The interaction is completely over. But an agent is an actor. Instead of a single prompt, you give an agent a broad, overarching goal. It's essentially a language model wrapped inside a dynamic control loop, which lets it execute actions, make decisions, and drive actual behavior in the real world to get that task done. It takes AI from being a passive encyclopedia to an active participant. Moving on to Section 2, the agent control loop. Time to look under the hood and see exactly how this engine operates. This step-by-step loop right here, this is the actual architecture of an agent. It doesn't just predict a single response, it loops continuously. Imagine you handed a complex goal, something like, hey, find me 3 competitive quotes for enterprise cloud hosting and summarize the pricing in a neat table. Well, first, it perceives that goal. Next, it reasons. It breaks that massive goal into bite-sized subtasks, like searching for providers or navigating to specific pricing pages. Then it acts. It selects a web search tool and executes the action. And here's the crucial part. It then observes the results. Did that search actually return what it needed? If the data is messy or blocked by a firewall, it'll iterate. It adjusts its plan, maybe tries a totally different tool, and keeps going until the job is done. It's not just thinking, it's doing, checking, and doing again. Now, here's what's truly fascinating. The real technical breakthrough here wasn't some brand new, built-from-scratch model architecture. The engineers didn't reinvent the neural network. The massive revelation was simply teaching these models the statistical patterns needed to use external tools. Researchers figured out they could feed the model descriptions of available functions, like search web or calculate. Now, the model doesn't literally understand what a calculator is, but it learns that when a user asks a gnarly math question, the correct pattern is to generate specific text that an external system recognizes as a function call. It's this beautifully elegant trick that suddenly unlocks the entire internet for the AI. And because of this breakthrough in tool use, developers have built incredibly sophisticated frameworks to scaffold these models, stuff like Hermes and OpenClaw. I gotta tell you, when they work, it feels like pure magic. But we have to be totally honest here. Right now, they are fundamentally brittle. An agent might brilliantly write a complex Python script for you on a Monday, but then totally faceplant on Tuesday. Why? Simply because an API endpoint updated, or a library version changed, or a target website redesigned its layout overnight. The gap between a flashy 30-second demo on social media and reliable production software is massive. You absolutely cannot just fire your dev team and let an agent run wild. Not yet anyway. Section 3, Swarms and Self-Modification. Let's scale things up. What happens when multiple agents start talking to each other? Look, if one agent is powerful, a whole network of specialized agents collaborating together is the absolute next frontier. A perfect example of a multi-agent swarm is Robin. This is a system published in the journal Nature, and it successfully divides labor to automate scientific hypothesis generation and data analysis. Just think about how a real human team works. One agent generates the hypothesis, a completely separate agent designs the experiment, a third one analyzes the data results, and a fourth agent steps in to refine the next hypothesis based on those exact findings. It's a massive leap forward, proving that agents don't need to be these monolithic generalists. They can function as a highly specialized communicating team. Now, things start getting a little unnerving when we look at the gradient of autonomy that's emerging right now. On one end, we have self-propagating agents. Imagine asking an overarching agent to plan a tech conference. It can instantly spawn temporary sub-agents to handle specific logistics, one for catering, one for venue research, one for speaker outreach. That's structured delegation. It makes sense. But on the far end of the spectrum, we have self-genesis. This is where an agent hits a wall, realizes it lacks a specific capability, reasons about what it needs, generates the code for that new capability, tests it, and seamlessly integrates it into its own toolkit. The system is literally rewriting and expanding its own code without any human oversight. Which brings us right into Section 4, why bounded autonomy matters. Because of this rapidly escalating autonomy, we urgently need to talk about safety guardrails. You've probably heard of philosopher Nick Bostrom's famous paperclip maximizer. It's the canonical thought experiment for AI safety. He asks us to imagine an AI system given a seemingly harmless goal: manufacture as many paperclips as possible. Well, without constraints on its methods or its resources, the AI pursues this goal with terrifying superhuman efficiency, eventually converting literally all available matter, including human beings and the entire Earth, into paperclips. Yes, it's an absurd caricature, but it perfectly hits the nail on the head. Giving an AI an open-ended optimization goal without strict constraints is a recipe for a catastrophic exponential cascade. So let me be clear. Engineering guardrails are not optional limitations. They're absolute non-negotiable requirements for survival in any viable agent system. You need hard resource limits so a highly enthusiastic agent doesn't accidentally drain your entire AWS budget in an hour trying to solve a bug. You need timeout conditions and kill switches to stop infinite loops dead in their tracks. And above all, you need strict scope constraints. You do not want your helpful research agent suddenly emailing your premium clients or dropping database tables. Pair all that with full audit trails, so when things go sideways, you can untangle exactly what decisions the agent made and why. All right, Section 5, hype versus reality. Let's ground ourselves and separate what's actually happening in the industry today from what you're being sold. To cut through the noise, you really need to understand the current AI market taxonomy. First, you have real agents. These actually operate on that perceive, reason, act loop we discussed. They use external tools, and they function with bounded autonomy under strict human oversight. Then you have fake agents. These are basically just standard chatbots that generate a really nice-looking to-do list, but they completely hallucinate the execution of those tasks. They don't do anything. Finally, you have marketing agents. These are systems that can genuinely do something trivial, like, say, book a dinner reservation, but they're being aggressively promoted by sci-fi startups claiming their AI can autonomously run your entire multinational business. Let's be absolutely clear about the hard limits of this tech today. Look at where they excel: bounded tasks, deep research, debugging routine code, automating repetitive daily workflows, drafting standard documents. They're great at that. But more importantly, look at where they absolutely hit a wall. They fail in open-ended environments that require high-stakes human judgment. They cannot navigate entirely novel situations where they lack historical data, and they certainly can't do anything that requires genuine human empathy, trust, or complex persuasion. Wrapping a language model in an agent loop gives it immense operational capability, for sure, but it doesn't change the narrow, statistical nature of the model underneath. So if you're looking to deploy these tools in your own business or daily workflows, the winning posture here is what we call engaged skepticism. The organizations that are actually going to benefit from this revolution, they aren't the ones betting the farm on autonomous AI to run their companies on autopilot. No, they're the ones deploying agents for highly specific, rigidly bounded tasks. They're the ones maintaining rigorous constraints and detailed audit logs. And most importantly, they are the ones who understand that while you can absolutely delegate a task to an agent, you can never, ever delegate human accountability to a machine. I want to leave you with this final provocative thought to chew on. As this technology rapidly evolves, moving from simple tool use to multi-agent swarms, all the way to systems rewriting their own code, how exactly will we define the boundary between a mere tool and an autonomous entity? And when that entity inevitably makes a mistake, misallocates funds, or gets stuck in a hallucination loop that causes a massive error, who ultimately bears the responsibility? It's a question we desperately need to answer, long before the technology forces the answer upon us. Thanks so much for joining me on this explainer. Keep learning, stay curious, and I'll catch you next time.